Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to be talking about the divergence test. So we're asked to use the divergence test to determine whether the following series diverges or state that the test is inconclusive. So we're given this series here from k is equal to 0 to infinity. We've got k over 2k plus 1. So the divergence test is just that. It's a divergence test. It doesn't tell us anything about the convergence of a series. And that's very important to note here because a lot of students will assume that a series converges. Because remember, for the divergence test, basically what it says is it says that if the limit, in this case as k goes to infinity, does not equal, for a sub k by the way, does not equal 0, then it basically says that our series a sub k will diverge. Now the reason why I brought that up is because, again, if we take the limit as k goes to infinity for a sub k, and let's say it doesn't, let's say it equals 0, well, students will assume, well, the series converges because it equals 0. But remember, the divergence test doesn't tell us anything about convergence, okay? So if it equals 0, we say it's inconclusive, okay? We don't know that it converges because that's not what this test tells us. And obviously, if the limit as k goes to infinity for a sub k does not equal 0, then obviously it diverges. But just to be very careful with the way that you are thinking about the convergence, or well, lack of convergence in this case, because it doesn't tell us anything about convergence. But just be careful how you think about the divergence test. It's a very, very misused test. Okay, so let's identify a sub k here. So a sub k here, obviously, it's just k over 2k plus 1. So let's see what we get here. So you get the limit as k goes to infinity. And we'll know we'll need to divide everything by the highest denominator power. So that'll be k divided by k all over 2k divided by k plus 1 divided by k. And what this does, it makes the limit easier to take. So now this becomes the limit as k goes to infinity. And after we do the simplification, this just becomes 1 over 2 plus 1 over k. And we'll take the limit now. Now when we take the limit as k goes to infinity for 1 over 2 plus 1 over k, that's obviously just 1/2. Okay. Now if you notice here, the limit as k goes to infinity for a sub k here, notice that it does not equal 0, which means that the series diverges by the divergence test. But be careful, again, if you take the limit and you do happen to get 0, that does not mean that the series converges. Be very, very careful with that. You say it's inconclusive if you end up getting 0. We can't say it converges because the divergence test doesn't tell us anything about convergence. So I know I sound like a broken record by restating that, but that is a very common mistake a lot of students will make. So in this case, we can say that by the divergence test, the series that we're given, a sub k, again, diverges by the divergence test. Because the limit as k goes to infinity for a sub k does not equal 0. So that is going to be your solution. Okay. All right. So let me know if you have any questions about that. But other than that, that's going to be it. And I will see you guys next time.